We humans tend to make some really fast things, some purposeful, others not so much. But what's the fastest? No, it isn't the nuclear-powered manhole cover. If you have no idea what I'm talking about, on August 27, 1957, scientists conducted an underground experiment known as Pascal B. A nuclear device was detonated at the bottom of a 500-foot shaft, sealed at the top with a 900-kilogram or around 2,000-pound steel plate. On detonation, the plate shot upwards at an estimated 125,000 miles per hour, more than enough to escape Earth's gravity. This made it the fastest man-made object at the time, and the quickest acceleration of any man-made object by far. Sadly, however, it is more than likely that the cover vaporized in the atmosphere and is not somewhere in space like many believe. However, even if it were speeding through space, it would still be dwarfed in speed by the Parker Solar Probe, the actual fastest man-made object. NASA's Parker probe was launched in 2018, with the primary purpose of studying the sun, specifically its corona and solar wind, by approaching it closer than any previous spacecraft. The probe flew 3.8 million miles from its surface on its closest approach to the sun. Although this is still incredibly far in terms of human comprehension, being over 152 Earths, the probe still experienced immense heat. Without its heat shield, called the Thermal Protection System, it would have burned up almost immediately. TPS for short is 8 feet wide and 4.5 inches thick. The outer and inner layers of the shield are reinforced carbon-carbon composite, which is strong and stable at extreme temperatures. This material was previously used in the space shuttle. The core is carbon foam, which is 97% air. This provides thermal insulation while keeping the shield lightweight. The sun-facing side of the shield is coated with a bright white ceramic layer made from aluminum oxide, designed to reflect as much solar radiation as possible. There's also a thin tungsten underlayer which prevents the coating from degrading chemically. While the shield can face temperatures up to 2,500 degrees Fahrenheit, the internal components of the probe remain near room temperature, around 85 degrees Fahrenheit. But why am I telling you this? Because it's cool. Anyway, during the probe's closest approach to the sun, it achieved an incredible 430,000 miles per hour. At this speed, the probe could circle the Earth around 17 times every hour, or once every 3.5 minutes.